Good morning. Today's tutorial video is on mechanical energy. Mechanical energy is the combined movement or kinetic energy and potential energy that an object has. What you hopefully saw in the investigation yesterday is that as an object falls, its potential energy is converted into kinetic energy. Or as an object goes up a ramp, like this object here, its kinetic energy, which was 100% at the time, will decrease until, if it makes it to the top of the hill, it's all potential energy. Then, of course, as the cart here is going down the hill, its potential is being turned into kinetic energy. So the formula for mechanical energy is pretty straightforward. Kinetic energy plus potential energy will give you your total mechanical energy. So we have an example here. A bullet, it has a mass of 0.084 kilograms at a height of 221 meters. It has a speed of 53.2 meters per second. The mechanical energy of the bullet is, so we need to find the potential energy because it is at a height, so it has energy. It's going to gain kinetic energy as it goes towards the ground. It also has kinetic energy because it's a moving bullet. It has a speed and it has mass. So the potential energy formula, mass times gravity times height. Okay, well my mass is 0.084. Gravity is 9.81 meters per second squared. I'm running out of space here, 221 meters. When I multiply those together, I get, as a number, 182. Let's write it here. 182.11284 joules. We're going to keep as all the digits because we have to add it with kinetic energy before we come to a final answer. So the kinetic energy aspect, the movement energy, kinetic energy is mass times velocity squared divided by 2. Well, mass, again, is 0.084 kg. Velocity is 53.2 meters per second squared. When I divide by 2, the answer I get for my kinetic energy is equal to 118.87 joules. My total energy, my mechanical energy, is those two numbers added together. So mechanical energy will be equal to 118.87 joules plus 182.284 joules. The answer I got was 300.982. Let's take a look to the question and the least amount of significant digits. I got here, my least significant amount of significant digits would be 2. So I need a 2-digit answer. My 2-digit answer will have to be 3.0, and I'm going to be multiplying that by 10 to the power of however many times I have to move my decimal place to the left, once, twice. 3.0 times 10 to the power of 2 joules. Hopefully yesterday you started to wrap your head around the law of conservation of energy. That is that energy cannot be created nor destroyed, only transferred from one form to another. So the amount of energy in a system always remains constant. If we look at this image down here, at some point someone did work. They turned this winch which lifted a weight. You've added energy from the work you did to this system because now it has potential energy. From here to the point that it hits the stake, it is going to have the same amount of potential energy at the top. That amount of energy is going to equal the amount of kinetic energy at the bottom. So that energy, all of it, gets transferred from potential into kinetic energy. In real life, some energy would be lost to things like wind resistance, would lose some thermal energy. The important thing, though, is that in the system, the change in potential energy is equal to the change in kinetic energy, and we can use that to solve problems. There's a bit in the notes that I'll get you to do on your own. You can double click this image to open it up as a Google Doc. But here's our example. If a 2 kilogram ball is dropped, what is the velocity of the ball right as it hits the ground? Well, at the top, we don't even have to do a calculation. It tells us that the potential energy is 100 joules. Right as it hits the bottom, the potential energy, because there's no height anymore, the potential energy will be 0. And because of the law of conservation of matter, all of that energy is going to be converted into kinetic energy. So now I'm able to relate the potential energy at the beginning, before I've dropped it, to what the kinetic energy would be right as it hits the ground, because it's the same. And then I'm able to find out what the velocity of the ball would be. So we look to our kinetic energy formula. Mass times velocity squared divided by 2. I'm looking for velocity. I've shared that document with all of the rearranged formulas. But what we need to do is just do the opposite of things to get velocity by itself. I'm going to multiply both sides by 2 to cancel out that divide by 2. I'm going to divide both sides by m to get rid of that times m. And then finally, to get rid of v squared, I'm going to do the opposite and find the square root of v squared. But I have to do the same thing to that other side. The square root of v squared is just v. And so my formula for velocity is the square root of 2 times the kinetic energy divided by mass. And so let's find that out. Two times 100 is 200. Divided by 2 is 100. So 2, I'll just write out the math. 2 times 100 is 200, but we have to divide by the mass, which is also 2. Pretty much cancels out. Velocity is equal to the square root of 100. Velocity is equal to 10. The terms that we're being asked to find out are in meters per second. So if we know the height and mass of an object, we can calculate its potential energy. We can then use that information to find out the object's velocity right as it's about to hit the ground. Because right as it's about to hit the ground, it has 0 potential energy and all kinetic energy. So the last type of question, and the type of question that you're going to be assessed on tomorrow, involves a skateboarder going up a ramp. At the beginning, at position 1, the skateboarder is on the ground. So the skateboarder has no potential energy. It's all kinetic. It's all kinetic energy. We are given a velocity, we're given a mass. Given those two things, we're able to calculate the kinetic energy. So kinetic energy is equal to mass times velocity squared divided by 2. Mass is 60. Velocity is 8 meters per second. Velocity squared would be, I don't want to confuse people, so we'll just say 8 meters per second squared. Of course, that ends up being 64 divided by 2. So 60 times 8 squared divided by 2 ends up being 1,920 joules. So that is our kinetic energy. We can write that in here. Oops, 1920 joules. That also happens to be all of the mechanical energy in the system. That's all of it. At that point, that's all the energy. So that ends up being 1920 joules. Because we're not pushing anymore, that also happens to be the mechanical energy for position 2 and position 3. Let's talk about position 3. This is at the top any longer, and they're going to start going back the other direction. The total energy for the system is 1,920 joules. At this point, when they're at the top of the ramp, just like your skateboarder in the interactive, their velocity is 0. And if their velocity is 0, their kinetic energy is 0. So all of the energy is potential. So because we know the mass, because we know gravity, we're assuming it's Earth, because we know the potential energy, we're able to find out the height that the skateboarder got to. So the potential energy formula is mass times gravity times height. Rearrange to get height by itself, I'm going to divide by these two things I'm multiplying, but I do it both sides. So gravity, potential energy divided by mass divided by gravity will give us height. The potential energy is 1,920 joules. Mass is 60. Gravity is 9.81. What we end up getting for our height is 3.26 meters. And that's at the top of position 3. I said position 2 for the end because it's the toughest one. We know that the energy in the system is 1,920 joules, but we're a meter off the ground and we're moving. So it's some combination of my potential and kinetic energy to get me there. I know the mass. I know the height he is off the ground. Let's find the potential energy at that point. So potential energy at position 2, the mass is 60. Gravity is 9.81. The height is 1 meter. When I multiply those together, I get, as potential energy, 588.6 joules. So we can use that to find the amount of kinetic energy in the system at that time, because our total energy has to still equal 1,920 joules. So 1,920 joules, our total, minus at that point our potential energy, is going to give us our kinetic energy. Kinetic energy is what's left over, 1,331.4 joules. So this is mechanical energy, and that's subtracting the potential energy, and that's going to equal kinetic energy. I can, now that I have kinetic energy, I can find out the speed of the skateboarder at that time. So I just had to pause there. My son was coming in the room hollering about something. What we did at position 2, just to reiterate, at position 2 I'm assuming that I'm moving and I know that I'm at a height off the ground. So my mechanical energy is some combination of potential and kinetic. I used the fact that I knew the mass and I knew the height to find out the potential energy at that height. And I subtracted that from the total energy because everything that's not potential energy is going to be kinetic. Once I know the kinetic energy, I know the mass, I have enough to find out velocity. So we remember our velocity version of the kinetic energy formula is the square root of 2 times the kinetic energy divided by mass. So that would be the square root of 2 times the kinetic energy was 1331.4 joules, and that's divided by my mass, which is 60. When I do that, I end up getting for my velocity 6.66 meters per second. That's at this point here. So again, what we were able to do at this point, if we had enough information to find our potential energy, we knew from the previous two parts what our mechanical energy was. We subtract to find our kinetic, and then we can work the equation to find velocity.